semiconductors. So first of all, we should understand the classification of materials on the basis of electrical conductivity. So on the basis of electrical conductivity, we can classify them into three types: metals, semiconductors and insulators. So metals, they possess very low resistivity or high conductivity, whereas semiconductors, they have resistivity or conductivity intermediate to metals and insulators. So insulators, they have high resistivity or low conductivity. Metals, one of the good example is iron or copper, which are the good carriers or conductors of electricity, and they have low resistivity. Semiconductors, good examples are germanium, silicon, which have resistivity or conductivity intermediate between metals or insulators. So insulators, they have high resistivity and low conductivity. They do not conduct electricity. So one of the good example is wood, glass, like materials. So first we need to understand energy bands, then only we can understand the different kinds of materials. So energy band, before that we should know, according to Bohr atomic model, electrons revolve in particular orbit. Okay, so when these electrons revolve in particular orbit in an atom, these atoms are going to be together so that solid can be formed. So each solid consists of what? Regular arrangement of atoms, or we can call that as crystalline material. So there is a periodic arrangement of atoms. In that case, what happens? These electrons see exactly the same pattern of surrounding the charges. Because of this, each electron will have a different energy levels. So these different energy levels with continuous energy variation form what we call them as energy bands. So we can have here the energy bands called conduction band and valence band. So conduction band is always above the valence band, which is always empty, whereas valence band consists of completely filled with electrons. So the gap between these two bands are known as forbidden energy gap. On the basis of energy gap, we can understand different kinds of materials. So some of the key points you should remember here: the energy band, which includes the energy levels of the valence electrons, is called valence band. The energy band above the valence band is called conduction band, which has no electrons inside that. If the lowest level is the conduction band, happens to be lower than the highest level of the valence band. So always electrons will move from valence band to conduction band. Normally the conduction band is always empty, but when it overlaps with the valence band, then only the electrons can move. This is the case only possible when metallic conductors are there. So how the energy gap exists between three different materials? Insulators, if we take, energy gap is very large. That's why they are bad conductors of electricity. Electrons cannot jump from valence band to conduction band. In case of semiconductors, energy gap is very small, of the order of 1 electron volt. So they can jump from valence band to conduction band due to some external energy. Whereas metals, they these bands, conduction band and valence band, will overlap. That's why the electrons can move easily from valence band to conduction band. That's why they conduct electricity, or they are good conductors of electricity. Semiconductors are the materials whose conductivity lies between insulators and metals. So let us understand the topic semiconductors clearly. Semiconductors are the materials whose electrical properties lies in between those of insulators and good conductors. Examples are germanium and silicon. In terms of energy bands, semiconductors can be defined as those materials which have almost an empty conduction band and almost filled valence band with a very narrow energy gap. So, types of semiconductors. Semiconductors are classified into intrinsic and extrinsic semiconductors. Example: silicon, germanium. Extrinsic semiconductors: p-type, n-type. Examples: phosphorus, arsenic, tin. N-type: aluminium, boron, gallium, indium. So, intrinsic semiconductors, as the name indicates, which are made of semiconductor material which are extremely pure form. So the purest form of semiconducting materials are known as intrinsic semiconductors. Silicon, germanium, which have the forbidden energy gap of about 0.72 and 1.1 respectively. The energy gap is so small that even at ordinary room temperature there are many electrons which possesses sufficient energy to jump across the small energy gap between the valence band and conduction band. So alternatively, an intrinsic semiconductor may be defined as one in which the number of conduction electrons is equal to number of holes. Means the valency of intrinsic semiconductor is always 4. So silicon or germanium has the valency of 4. We can see here silicon is surrounded with 4 valence electrons and there are equal number of holes, 4 holes and 4 electrons. That's why valency is 4. This is an example of intrinsic semiconductor. Extrinsic semiconductor, those intrinsic semiconductors, when we add dopant or impurity to them, we will get, and the dopant must be extremely small, we will get the extrinsic or impure semiconductor. Some of the examples as I have given extrinsic semiconductors, but we have divided on the basis of adding impurities into n-type and p-type. So first we will understand n-type semiconductors. As n-type semiconductor, we have here the majority carriers are electrons and minority carriers are holes, and the dopant used here is pentavalent. It is seen from the above description that n-type semiconductor, one of the good example is arsenic. If we add impurity to the germanium, pure semiconductor, as arsenic as dopant, then we will have the excess of electron, that is pentavalent. So electrons are here majority carriers, holes are minority carriers. P-type semiconductor, so when we add the trivalent dopant to the pure germanium or silicon semiconductor, then we will get p-type semiconductor, and here in this we can have one void or vacancy around the boron, so that will make the majority carriers here are holes and minority carriers are electrons. The semiconductors are mainly used in the manufacturing of electronic devices like capacitors, transistors, diodes and integrated circuits, and are widely used in many devices for their reliability, compatibility, power efficiency and cost efficiency. So this is all about semiconductors. Hope this video is helpful for you. If you found this video helpful, please like, share and subscribe my channel. Thank you for watching.